Okay, this section is on word problems related to angles of elevation and depression. It's a way to indirectly measure something, so you're not actually getting out a measuring stick or a tape measure and measuring it. So to describe each angle, what you have to look for is these are your parallel lines right here. So the smiley face is looking up at the star, and the star is looking down at the smiley face. The smiley face is looking down at the heart, and the heart is looking up at the smiley face. So if we're going to describe angle 1 right here, angle 1 is called an angle of depression. It's going down. Angle 1 is looking down with respect to the parallel line. So it's the star looking down at the smiley face. So it's an angle of depression from star to smiley face. Angle 2 is with respect to the horizontal right here, or the horizon, is looking up at the star. So if you're looking up, it's an angle of elevation from the smiley face to the star. Angles of elevation, angles of depression are always touching or adjacent to the horizontal line. These angle 1 and angle 2 are congruent. These are called alternate interior angles. So those two angles are congruent. So if you know the angle of elevation, then you can figure out the angle of depression in that scenario. Angle 3, it's touching the horizon, but it's going down. So this is an angle of depression from the smiley face to the heart. Angle 3 is congruent to angle 4 because of alternate interior angles. And angle 4 would be an angle of elevation from the heart to the smiley face. Okay, so when you do these types of problems, you want to draw the alternate interior angles. You want to draw the two parallel lines, and you want to make sure that your angle of elevation, angle of depression are touching, adjacent to the parallel lines. So in this next one, a surveyor stands 200 feet from a building. So you have a surveyor. He stands 200 feet from the building. To measure its height with a 5-foot theodolite, a measuring device. Okay, so I guess this is 5 feet. And we don't know the top of the building. The angle of elevation to the top of the building is 35 degrees. So we have to draw our parallel lines in. Right here. So I'm going to draw the distance right here. We always want to set up a right triangle. How tall is the building? So we're trying to find this whole part right here. But first what we need to do is we're going to find, I'll change color here. We're going to look at this green triangle. We know in this green triangle this is 200 feet. We know that this angle is 35 degrees because that's the angle of elevation. People mess up by putting 35 degrees right here, or they put it right here. But remember, 35 degrees has to be touching the parallel lines. So this is 35 degrees and this is 35 degrees. So we're going to use, we have the adjacent, and we not want to know the opposite. So we're going to use tangent. So it's the tangent of 35 degrees equals opposite, which is x. We're going to actually find this first, over adjacent, which is 200. So So I don't have my scientific calculator here, but what you're going to do is, to find what this is, you're going to multiply 200 times the tangent of 35. That's going to give you this black part. So to get the final answer, which is this blue part right here, you need to add 5 to that. So your answer is going to be 200 times the tangent of 35. Maybe you want to put this in parentheses, plus 5. And make sure you answer in feet, so you can calculate that. But I'm just helping you set it up. Okay, number 2. An airplane flying 3,500 feet above ground. So the airplane is 3,500 feet above ground. Begins a 2-degree descent to land in an airport. So we'll call this the airport. How many miles from the airport? So when we're talking about miles from the airport, you're talking about this distance right here. Unless it says the actual distance between the airplane and the airport. The actual distance between them would be this distance right here. Talking about ground distance is this distance. So we'll call this x. When it starts its descent. So again, we need to draw in our parallel line and mark off the 2 degrees. The 2 degrees is not right here. The 2 degrees has to be touching the parallel line. So this is 2 degrees and this is 2 degrees. So now I'm trying to find x with this triangle right here. So I'm going to use tangent again because it's opposite and adjacent. So I write the tangent of x, or tangent of 2 degrees, equals the opposite, which is 3,500, over the adjacent, which is x. So in this case, to solve for x, you multiply both sides by x. So it's x tangent of 2 degrees equals 3,500. I don't have my calculator, but your answer is going to be 3,500 divided by tangent of 2 degrees. And make sure, since we're talking about feet, that you answer in feet. Okay, number 3. An airplane pilot sights a life raft at a 26-degree angle of depression. The airplane's altitude is up and down, that's like the height, is 3 kilometers. What is the plane's surface distance? Surface is on the bottom. So we're talking about, I'll draw an airplane right here. So we got an airplane again. And we have this life raft. The altitude is 3 kilometers. The surface distance is going to be this. So we'll draw our parallel line again. So it's 26 degrees. The 26 degrees needs not right here, it's right here. It's close to it's touching the parallel lines. So I write this is 26 degrees, this is 26 degrees. So again, you're going to use tangent because you have opposite and adjacent. So you do tangent of 26 degrees equals 3 over x. And then to solve for x, you multiply both sides by x. So x tangent of 26 degrees equals 3. And your answer is going to be divide both sides by tangent of 26 in your calculator. So x is, you're going to round, so it's approximately, because this will not be exact. And then you're going to answer in kilometers, because that's our unit right here. And then the last part, a 6-foot man, this guy's 6 feet, stands 12 feet from the base of a tree. The angle of elevation from his eyes to the top of the tree is 76 degrees. How tall is the tree? So again, this is 76 degrees right here. This is 76 degrees. This is 12. We're trying to find this distance first, just like the first example. And then at the end, we're going to add 6 to it. So I'm going to do tangent of 76 degrees equals opposite over adjacent. So x equals 12 times the tangent of 76. But that just gives me this black part, but I want to find the total height side of the tree, so I have to add 6 at the end. So I add 6. So if you're putting this calculator, make sure that you close off your parentheses after the 76. Answer in feet. B. If a man releases a pigeon that flies directly to the top of the tree, how far will it fly? So you're trying to find this distance. This is the distance of right here. Right here. So they'll call this y. So to find y, I'm actually going to use, I have the adjacent and I want to know the hypotenuse. So I'm going to use cosine. So the cosine of 76 degrees equals adjacent 12 over hypotenuse, y. So to solve for y, you multiply both sides by y. So it's going to be y cosine of 76 equals 12. Divide both sides by the cosine of 76. So this cancels out. So y equals 12 divided by cosine of 76. Put that in your calculator and round it, and you're going to be talking about feet. And then the last question, what is the angle of depression from the tree to the man's eyes? It's going to be 76 degrees because the angle of elevation and angle of depression are congruent because of alternate interior angles.